Hello, everyone. Welcome to Echo Live. My name is Julia, and I'm so excited to be here today. Go ahead and put your name in our chat, introduce yourself, let us know where you're viewing from, and just sit back and relax because we're going to have a good time. We're going to learn about science, and we're going to have fun too. So today we are going to be talking about one of my favorite subjects. We are going to be talking about sticking with chemistry. We're going to be talking about chemistry today, and specifically the kind of chemistry that you can do at home. Now, the reason for this is because this week is National Chemistry Week, and we are going to be doing a lot of experiments that you can find through NISENet. So stick with me and we will stick with chemistry. All right. Now, as we get started, I'm feeling a little famished. So I actually brought a salad today because I am starving for science. Now, I have some kale because I like to stay healthy. I also have just some regular lettuce here. And before I have this lettuce, of course, you know, I can't just eat plain lettuce. I also need some dressing. So I brought some dressing from home. I have some oil, some olive oil, some red wine vinegar, and I went ahead and put that inside a mason jar because I like to reuse whenever I can. And let's go ahead and shake this up so it'll be ready for my salad. Perfect. So as you can see, that's nice and mixed up. So we're just going to set that aside, come back to it. And I'm just going to wash my lettuce real quick. You know, before I do that, though, we could actually do a fun experiment with this. Because when you watch water rolling off of lettuce and kale, some really interesting things can happen. So let's go ahead and take a closer look. So we have our kale here and our lettuce. So I just have some water here. And if I put that water on the lettuce, nothing too shocking happens. It gets wet, no surprises there. But let's see what happens when we put water on the kale. So that water actually starts to bead up and rolls right off our kale. This is actually something known as the Lotus Effect, named after the lotus plant. So this is what a lotus plant looks like. And as you can see, that water tends to bead up and just roll off of the plant. Now, in celebration of National Chemistry Week, we are looking at hydrophobic and hydrophilic properties. So the Lotus Effect is what we call a hydrophobic property. So this is what the lotus leaf looks like if we were to get it really, really big, much bigger than we can see with the human eye. You'll see there's sort of these little peaks and valleys. This is on the nanoscale. Once again, extremely, extremely small. So if we could zoom in on our kale leaf, this is what it would look like. And those drops of water just kind of bounce around on top of our leaf. Now, there's something else I have with us today that is also hydrophobic, and that is actually my salad dressing. As you can see, let me help you see it a little more clearly. What is happening? My salad dressing. My salad dressing is separating. That's because oil and vinegar do not mix, because oil is hydrophobic. It does not like water. It doesn't want to go near the water. It is so afraid of water. It is most definitely hydrophobic. Now, hydrophobic properties, they want nothing to do with water, versus hydrophilic. Hydrophilic properties love water. And our vinegar is hydrophilic. But unfortunately, these two substances won't mix. Now, there is another scenario where we will see these kinds of properties in action, and that's going to be with a lava lamp. And you can actually find a do-it-yourself tutorial on our website, one of our fun activity guides that'll show you how to make your own lava lamp, just like this one right here. And much like my salad dressing, this lava lamp has oil and water. And we can see they really do not want to mix. And we're going to take a closer look at that. So we can see they really, really do not want to mix. But I like experimenting. And what's fun is when you are at home, you can experiment too. That's what being a scientist is. It doesn't mean having all of the answers. It's just about observing your environment, taking note of what you see, and having an open mind. So I have some Alka-Seltzer, something you can easily find at home, especially if mom or dad love spicy food like I do. And we're going to drop this inside of our lava lamp and see if that mixes everything together. So let's go ahead and take a look at that reaction and see what's happening. Oh yeah, it really does seem to be mixing, huh? We're definitely getting a chemical reaction. So maybe that's all it takes, is a chemical reaction, and our substances will mix. But here's the other part of science. Don't count your results until they're done. We're going to keep an eye on this, see how it looks, because in science, we don't take anything for granted. We're always willing to take a closer look and change our mind if we're given new evidence. So I'm looking at our lava lamp now, and while at first it looked like it was mixing together, I'm noticing that it's starting to separate. It's going right back to the way it was before. It looks like the fizz from our Alka-Seltzer made the oil rise up, but it didn't actually make them mix. What to do? Well, at home, we probably have some dish soap because we're all staying safe during coronavirus and washing our hands. And I have some dish soap right here. And let's try some dish soap, because we are home experimenters and we like to try things out. Ooh, does this look different? Let's take a look. That certainly does not look the same. And I think I know what's going on. You see, soap is something that we call an emulsifier. An emulsifier has both hydrophobic and hydrophilic properties. And so it can act like a bridge between two substances that do not want to mix. Because when that emulsifier is added to our, say, our lava lamp, it creates something known as a micelle. Let's take a look. Now, a micelle is a little round structure like the one on our screen. Again, much too small for us to observe with the naked eye. These are things that are very, very tiny, but it has a hydrophobic core. So all of the oil goes to the core, and the hydrophilic, and it has a hydrophilic shell. So it kind of creates these tiny compartments, and it holds that oil and it holds that water so that they mix together and can play nicely with each other. And if we look at our experiment, we'll see that it's still holding together. It's still holding together. Now, if only I had brought some mayonnaise, I might be able to get my salad dressing to mix, because mayonnaise is also an emulsifier. You know, I might have brought some mayonnaise and put it in the refrigerator, but I'm having too fun doing science, so I'm just going to set this aside, and I'll make sure to emulsify it later when I'm ready to eat. So these properties actually have some really cool uses. Now, we're all probably familiar with kind of a scary event, oil spills. Oil spills are a huge problem in our modern world. And scientists are trying to figure out ways to protect wildlife from oil spills, and of course, to help humans, because oil spills are not good for our environment either. So, how can we use emulsifiers to help us with oil spills? Well, why don't we go back to my salad dressing? So we've all probably seen videos of ducks being cleaned with soap, and that's because they're using an emulsifier to get that oil off of the duck. Because otherwise, trying to get oil off with water just isn't going to work. It's going to be like our salad dressing, where the oil and the water don't want to mix. So the water can't actually carry the oil away, it sticks. But if we add an emulsifier, and luckily I have some delicious mayo right here, which is an emulsifier. We can get those two substances to mix together. And what's fun is this is something you can do at home. You can have a fun science experiment. Oh, and a great dressing too. And so we are able to use an emulsifier like soap on our duck friends, our bird friends, to get all of that oil off of these birds. But there's a problem. One, we don't want to put emulsifiers into the ocean, because the fact that oil and water don't mix is actually a good thing. So we don't want these two substances mixing together. And for our favorite fowl, it's not good for these animals to get coated in oil. It's very, very harmful to these animals. And once they are covered in oil, it's not likely that they're going to survive. So even if we clean them with an emulsifier, it's often not enough, and less than 1% of those animals will survive even after being cleaned. So this isn't very effective. So how can we use hydrophobic and hydrophilic properties to stop these oil spills quickly and keep that oil from even getting to these animals in the first place? Well, I'm so glad you asked, because we can do that with everybody's favorite toy, something you may have at home and something that's very easy to make if you don't have it at home. We'll be posting a tutorial right in our chat. You can also check out NiceNet. They have this activity for this wonderful toy called Magic Sand, or Kinetic Sand, as it's sometimes called. They have tons of fun experiments that you can do right at home. So we're going to take a look at some kinetic sand and look at how it can be used to clean up oil spills. Now, I have some right here. I have some kinetic sand and some regular sand. Now, I remember when I was a little girl, I loved playing with sand. I loved how it felt on my fingers. I would sit and I would hold it and I would wonder, where does sand come from? Why is it so soft? Why is it so darn fun to play with? Even as an adult, I still love sand. And so this is such a fun experiment to do. So first, let's take a look at some regular sand. So bear with me while I get you a good view. So we have some regular sand here. And even though it's not kinetic sand, it's so fun to play with. And it feels so great on your hands. And you can feel the individual grains. It's such a great textile experience. Now we're going to look at some kinetic sand. And we're going to use an orange tray just so we can keep track of the different kinds of sand that we're looking at. Ooh, I want you guys to see this because this is pretty cool. I don't want to hog all the cool stuff to my, check that out. Our kinetic sand kept its shape. Let's take a closer look. How cool is that? It's like a sand castle. I can't even karate chop it. Look at that. So fun. It's like cake batter. Now, what's really cool is this was actually developed to help us clean up oil spills, because this sand is really good at absorbing oil and not mixing with our water. Now, I don't want you to take my word for it, because remember, in science, we don't take anything for granted. We question, and we do our experiments so we can see this phenomenon on our own. So I'm just going to grab my pitcher of water. And if you do this experiment at home, I would recommend measure out about 1 cup of water. And we're going to do our control first. So we're going to take our regular sand and we're just going to put it in the water. And we're going to see what it does. So let's go ahead and take a closer look. I'm going to move our kinetic sand so we can see a little more clearly. Yuck. Gross. Not very pretty. All right, so we're going to fill up another cup of water. Water is one of my favorite chemical substances. I highly recommend trying it if you haven't. It's necessary for life as we know it. It's fantastic. All right, we're going to add our kinetic sand and we're going to take a closer look. Ooh, I'm so excited. Let's see. Let's see what it does. You know what? I'm just going to put a whole bunch in there because it doesn't seem to be mixing. So I'm just going to, you know what? Go big or go home, right? Let's see. Let's just get that all in there. Remember, science doesn't have to be perfect, doesn't have to be pretty, but it's always fun if you go into it with the right attitude. All right. Well, I've squished that pretty well in there. Let's take a closer look. Let's see. Oh yeah, that's really squished in there. So I'm going to get that sand out. Ooh. Uh-oh. Whoa. Remember, I want you guys to see this, because remember, science doesn't have to be pretty. It is very, so someone is asking if it's heavy. It is, because it's holding on to oil. Part of what makes kinetic sand, if you try to make it at home, is the fact that you make it with oil. And so it's very heavy because it's holding on to that extra matter, to that oil, which gives it a lot of weight. Now, I might have gone a little overboard, but that's fine. I'd rather go overboard than under. And what's really cool is this kinetic sand really just does not want to absorb that water, which is so great for cleaning up oil. And I should be able to pour some of this water actually from my tray here, because that water just keeps separating. And I want you to see how much water I was able to save, even with this huge mess that I've made. So we lost about half of the water, and that was just through me handling it. But that's still quite a bit. Now, if we were to do, see, we can even add a little bit more water because the water just keeps separating from our kinetic sand. And we could do the same experiment with our regular sand and compare and see, do we have more water? Do we have less water? You know, those are the kinds of questions that are fun to ask at home and experiment and try out yourself. So what I want you to take away from today is that we looked at hydrophobic and hydrophilic properties, and we saw how we experience these properties every day in our own home. When we're making a salad, when we're making dressing, when we're playing with sand, and that these are the same properties that are being used to solve some really major problems in the world. And so you don't have to have a big fancy laboratory. You don't have to have a lab coat like me. You can do science with so many things at home, as long as you have a can-do attitude and just an insatiable thirst for knowledge. Now, I want to save some time for questions. So if we have anyone with any questions or something that you'd like to take a closer look at. And while I wait for those questions to come in, I do want to thank our sponsors today. We have two sponsors who were generous enough to bring this program to you. Those are Ford and Denso. And I'd like to give a big thank you to both of our sponsors. Now, thanks to Ford and Denso, we will continue bringing you science through the rest of the year, every Wednesday at 2:30. So we have a question, how does it feel? How does it feel? It feels wonderful. It's so cool. You can shape it like cookie dough. It feels like cookie dough. It feels like cake batter. Are there any other experiments I'd recommend to do with kinetic sand? Yes. Shaping kinetic sand is very, very fun, but it also is it's a good tool to see how kinetic sand moves and to think about how different forms of matter move. You can use different oils to create kinetic sand and see how different oils affect how your kinetic sand moves. And so we have, so once again, oil is, someone was asking about the what is a hydrophobic property and what is a hydrophilic. Oil is a hydrophobic substance, meaning it wants to get away from water. It doesn't like water. It won't stick to water. It's repelled by water. Ugh. Hydrophilic substances like vinegar or water, like for example, water loves being around water. It loves itself. Oh, it just loves being being around itself. And hydrophilic and hydrophobic properties do not like to mix, which is why our kinetic sand, which is hydrophobic, doesn't mix with our water. So kinetic sand, we have someone was asking a question if kinetic sand comes from rocks. It does not. All right. And did we have any more questions? Okay, well, thank you so much, friends. Feel free to reach out in our chat if you have any questions. And of course, you can always come down to the Michigan Science Center and visit me. My name is Julia. I'm always happy to see my young scientists. Thanks again, guys. And remember, don't be afraid to get your hands dirty with science.